Welcome to Mbuya Parent School and Kindergarten, situated in Kampala City with modern, well-equipped facilities plus extensive playing fields and amenities. Mbuya Parent School believes that a better future lies where children know how to find and create balances in themselves and the world around them. This explains our fusion of academic subjects and co-curricular activities. There are many opportunities presented to them to flourish both in and outside the classroom.
I want to become a president when I grow up.
I want to be a pilot.
I will be the best fashion designer.
Mbuya Parent School, the sky is our limit.
Our dear learners, my name is Joseph Waifumo. Once again, I'm here to take you through a lesson of mathematics, primary 7. It will be lesson 6, but before we have our lesson 6, we shall have some corrections of the activity which we had in the previous lesson 5, which was talking about finding area of a trapezium. We had 2 numbers, but I'll go through only number 1 as a matter of reviewing what we had in lesson 5. Our activity required us to find the area of the figures, which figures were about a trapezium. It says, find the area of the following figures. And we have 2 figures. We have figure 1 as a right-angled trapezium, and we have figure 2 also a right-angled, figure 2, an isosceles trapezium. Since this one is more familiar, let me go through number 2, which is the isosceles trapezium. It is given with the height of 9 centimeters and its down line here as 8 centimeters and this one as 12 centimeters. We shall straight away have the formula which guides us to the calculation directly. The formula for finding area of a trapezium is simply given as A standing for area, which is given as a half H into A plus B. The H is the height, then the A will be this short line, then the B is this long line. So the next step will be substituting. Where H is, we have put there 9 centimeters, and the A is constant, representing area. So the a half is also constant. Then we shall multiply by 9 centimeters as the H, meaning the height. We shall multiply by the sum of A, which is 8 centimeters, and 12 centimeters. We shall not cancel at that very level because the 9 is not a multiple of 2. That means you shall have first of all to get the sum of 8 and 12, which is, of course, 20 centimeters. We are having A for area as a half times 9 centimeters, then multiplied by 20 centimeters. At that level, now we are good to cancel 2 by 20 centimeters because it is now the multiple of the 2. shall cancel by 2, this being 1, and when we cancel the 20 centimeters by 2, we shall get the result as 10 centimeters. We shall go ahead to maintain our S standing for area, which is now 1, this one here, times 9 centimeters, that one there, and finally by 10 centimeters, this one here, which will, of course, at the end, give us 90 square centimeters as our area for the trapezium. At that very point, you use your ruler to underline your answer using double line for smartness of the work. That is part of what we had in lesson 5. Our lesson for today, lesson 6, is about finding the unknown side, perimeter, and area of a trapezium. Remember, in lesson 5, we only dwelled much on finding the area of the trapezium. But for this case, we have almost 3 tasks. 1, finding one of the missing sides. 2, calculating the perimeter, and still part of the area, much as we discussed it in the previous lesson. And our example 1 goes, below is a trapezium. Use it to answer the questions that follow. And the trapezium is RSTU. The RS is given as 11 centimeters. The ST not given. The TU is given 17 centimeters. Then UR is given as 80 centimeters. And the first part of that particular question says find length ST. Find length ST, that slanting side of the trapezium. This is still our trapezium, where I've said the RS is 11 centimeters. The ST not given. The TU as 17 centimeters. All of this is 17 centimeters. All of it is 17 centimeters from here up to here. Then the RU is 8 centimeters, and we are required to get ST. When you look at this diagram, it has been subdivided into 2, where we have the rectangle and the triangle, meaning that this rectangle has this part, the RU, as 8 centimeters. The RU is equal to SV, meaning that also this one is 8 centimeters. Then the RS is 11 centimeters, and we find that it is also equal to UV, meaning that UV is also 11 centimeters. But we had it at the beginning that the UT is 17 centimeters, meaning that from here up to here will be got by having the difference between 17 and 11. We shall have to subtract. We are starting by getting length VT, where length VT is 17 centimeters minus 11 centimeters. This is 6, and here is 0, meaning that our length VT is 6 centimeters. We are doing all of this because there is that element of Pythagoras theorem that will aid us to get length ST. However, you must know that this one, which we are calling the triangle, is a right-angled triangle, meaning that we shall now extract it. We shall extract it to aid us getting length ST. This is a right angle. This is 8 centimeters, and here is 6 centimeters. This is our V, this is S, and this is T. From there, following the property or the theory of Pythagoras theorem, we shall have this as A, this is B, and this is C. The slope is always given, let us see, the hypotenuse. Now we are going to have the A squared plus B squared equaling to C squared. The next step will be substituting. Where there is A, we put 6 centimeters, but it is squared. Then we are adding 8, which is also squared. And this will give us C squared. Here we are going to square the 6, including the units. So when we square 6, we shall get 36. Then when we square the centimeters, that will be square centimeters. We shall add the square of 8, which is 64. And we shall also have the square of the centimeters, which will be square centimeters. This one giving us the result of C squared. At that level now we are going to add the 36 and 64, which will give us 100, and of course the units as 100 square centimeters equaling to C squared. From that point, we are supposed to eliminate the square part of it, because the question requires us to get length ST, which we have given letter C. But in our calculation, we have a point where it is C squared. So we have to eliminate the square part of it. So at this particular level, we shall introduce the square root symbol on both sides, so as to eliminate the square part of it. So we have the square root of 100 square centimeters, which is equal to the square root of C squared. Take note of this when you are drawing this square root symbol. If it ends somewhere here, it means you have only catered for the 100 and then it's out. Therefore, I'm emphasizing that let the square root symbol go up that level. So the square root of 100 is 10, then the square centimeters is centimeter. Then it will be equal to C, which is the square root of C squared. So we have this as our C. Coming back to the question, it does not say that find the value of C. It says find length ST, whereby length ST is now our C. So we shall come and say that length ST is equal to 10 centimeters. As usual, the point of underlining the answer is very important. You get your ruler, don't use a free hand. Get your ruler and underline the answer for smartness of your work. So after underlining our answer for part A, we can now answer part B of the question, which says, work out its area. When we talk of it now, we are meaning the trapezium. Which trapezium is RSTV? I mean RSTU, where we shall have the formula as this is part B. We are having our area denoted with the letter A as a half H. A half H into A plus B. And for this case, our A is 11, our B is 17, and H, which is the height, is 8 centimeters. And we are having the second part for substitution automatically. This is 8, then multiplied by the sum of A and B. That is 11 centimeters plus 17 centimeters. We may cancel from that very point, since we already have the 8, which is a multiple of 2. So cancelling can be done at that very moment. Cancel by 2, this is 1. Cancel by 2, this is 4. We come down and have 1 times 4 centimeters. Then we multiply by the sum of 11 and 17, which is, of course, 28. And these are centimeters. From that level, you can check the remaining part is now to get the product of 1 and 4, then 28, whereby I will advise you to come and multiply vertically. This is 28 multiplied by 4. Show the multiplication symbol. 8 multiplied by 4 will give us 32. We shall not write all the 32 at once. We shall write the digit in the place value of 1 was, that is a 2. Then we regroup, we take the 3, which is now the 30, in the place value of 10 is, that is a 3. Then we have 2 multiplied by 4. It will give us 8. At that moment, we shall add the 3, which we had here, giving us 11, whereby finally it will give us 112. But when we bring it here, we shall write it with its units, 112. And this is square centimeters, because the question demands is for area. And the area is given in square units. However, when you are writing the units, be careful, because some children end up cramming units, which is very dangerous. We have question C, which demands for the perimeter. Remember, our major concern for today, we wanted to find side of the trapezium, which was missing, the perimeter, and the area. We have so far done 2 things, the length of one side, the area, and now we are doing with one part, and that is the perimeter. This is the quadrilateral, which has got 4 sides, meaning that in order to get the perimeter, we must be aware of all the 4 sides. We have this part, 11 centimeters. We have this part, which is ST. Good enough, we have already calculated for ST in equation A, which was 10 centimeters. So, including that measurement on the diagram is very good before you add to get the perimeter. Then TU is 17 centimeters, and UR is 80 centimeters. So, shall therefore go ahead to answer question C, which calls for the perimeter, which I abbreviate with the letter P. And this will be given as sum of all sides. Sum of all sides. before you get perimeter of any polygon, first find out this polygon has how many sides. For this case, we have 4 sides, meaning that even your addition will cater for the 4 sides. So we are having the top part of it, the RS, which is 11 centimeters. We have the ST, which is 10 centimeters. We have the TU, which is 17 centimeters. And finally, the UR, which is 8 centimeters. So we are adding the 8 centimeters. So we have our 4 sides, 1, 2, 3, 4. From there, for easy additions, you can choose now to combine 2, 2. You can first add 11 and the 10, then 17 and the 8. This is 11 plus the 10. This is 1. 1 plus 1 is a 2. Meaning that for the first 2 values, we have got the 21. Of course, these are centimeters. Then the 17 and the 8 also will be added. This is 17 plus 8. 7 and 8 will give us 15. We shall write the 5. Carry the 1. The place of 10 is. It finds the 1, which will give us now a 2. Down here there is nothing, meaning this is 25. So we are adding the 25 on 21. Still we have 21 plus 25. In most cases, adding it horizontally like this, it is somehow challenging. I therefore advise you children always to bring it vertically. Add it vertically still. We are having 21, and this is 25. And I advise always do it the way I'm doing it, because some of you, you get the pen and calculate from here. Some of you write on your uniforms, other children write on their other parts of the body. These are the calculations. All parts of the question in the calculations must be reflected on the very area where the major calculations are reflected. Don't write this work either here or any part of the body, because this work is very important. The person who is going to mark this work has to see how have we arrived at the final answer. So we are having this as 6 and this as 4, where we shall finally have to say that perimeter for this trapezium is 46. Don't forget the units. These are centimeters. So from there, come and underline your answer for neatness. Underline your answer for neatness. Those of you who have been listening from the beginning, I'm very sure you can now attempt any question concerning a trapezium. Lesson 5 and lesson 6 have purely guided us on how to handle issues concerning a trapezium. So we have a simple activity. Why am I calling it a simple activity? Because we have already gone through it. Therefore, you'll find it very simple to attempt those numbers. I'm always happy, considering the previous lessons, you have always done those activities well. And even I'm very sure, even though this one here, you're going to do it well. I summarize this lesson by wishing you a nice day, by wishing you good life, by wishing you everything well. We are in the era of COVID-19. This disease is still on, so take care always wash your hands with clean water and soap. And of course, those of you who can afford sanitizer, please do sanitize. And these days, it is becoming mandatory that we are supposed to wear masks whenever we are going to public places to mix with other people. Allow me to end here. I wish you well. May God bless you.